The new LTX model is here. This is LTX 2.5. Today I'll show you how to run LTX 2.5 in ComfyUI and address 3 issues that can directly affect your results. Why do multi-shot prompts sometimes create cuts and sometimes remain a single continuous shot? Why does first and last frame generation sometimes introduce an unexpected transition? And why can videos with complex actions look beautiful while still breaking the laws of physics? Let's start with 3 results. The first is a vlog featuring an East Asian woman. Within 10 seconds, she travels from the Great Wall to Tokyo and then to Paris. That gives us 3 locations, 3 lighting conditions, and 3 different shot sizes, while the character's identity still needs to remain consistent. The second video shows a woman repairing a bicycle. She inspects the chain and then tests the wheel. The third video shows a woman closing an umbrella, but as she does it, the umbrella ribs suddenly become soft and flexible. This is one of the typical problems we encountered while testing LTX 2.3. LTX 2.5 still supports the fundamental workflows we're familiar with, including text-to-video, image-to-video, first and last frame generation, and synchronized audio-video generation. Compared with LTX 2.3, however, version 2.5 strengthens the entire pipeline from prompt understanding and latent generation all the way through to pixel reconstruction. First major improvement is a new technique called Diffusion Fidelity Rendering. You can think of it as redistributing the model's computational budget. Areas such as the sky or a blurred background are less likely to expose obvious mistakes, so the model can spend less time on them. Faces, hands, text, fast motion, and complex textures are much easier for viewers to notice, so the model spends more time processing those areas. In this close-up, the character begins by reading a card, then looks out the window, and finally turns back toward the camera as the shot continues to push in. Despite that movement, her eyes, the corners of her mouth, her skin, and her hair don't quickly turn into a blur. That's a very direct example of the model preserving high-frequency detail. Second improvement is a diffusion-based video decoder. A traditional VAE is more like translating a latent representation into pixels in one pass. During that translation, fast movement and fine textures can easily be lost. The new method is more like translating the latent first, and then performing an additional refinement pass with particular attention paid to those details. Third, LTX 2.5 uses a new text encoder. This makes the model feel more like a director who can follow instructions accurately, keeping track of the characters, action sequence, lighting, and camera movement described in the prompt. Take the bicycle repair example. This isn't simply a generic shot of someone fixing a bike. It contains 5 consecutive actions, and the model completes most of that sequence. This shows that its understanding of action chains has genuinely improved. But there's still a problem. When the camera turns toward the bicycle wheel, the character's face leaves the frame. When her face appears again, you can see that the facial identity has drifted. The fourth improvement is native multi-shot support, which we'll examine through 2 dedicated examples later. Now, let's look at how to run LTX 2.5 in ComfyUI. ComfyUI already supports LTX 2.5 natively. Update ComfyUI to the latest version, open the official templates, and you'll find the corresponding workflows. There are quite a few model files, but you only need to remember 3 things. First, the main model comes in both dev and distilled versions. The dev model is generally intended for model training. For everyday use, choose the distilled model because it's faster. ComfyUI also provides a dedicated int88 convert version. Second, we use the 12 billion parameter text encoder to help the model understand the prompt. There's also a node called Generate LTX2 Prompt. This is a prompt generator, or prompt enhancer. When you're not sure how to write the prompt, you can use this node to expand it. The official upscaling models also come in 2 types. One is a spatial latent upscaler, and the other is a temporal latent upscaler. The spatial model performs spatial super resolution, while the temporal model is mainly used for frame interpolation. For easier testing, I've also built the workflows on Running Hub. In the ComfyUI space, Running Hub is a great online working platform because whenever a new model or extension appears, it usually adds support very quickly. Running Hub also provides an online community for ComfyUI creators, where you can find plenty of creative inspiration and example workflows. Let's begin with the image-to-video workflow. The first section loads the models, including the main model, Virginia E Text Encoder, and upscaling model. If your prompt is relatively short, you can enable the prompt enhancer here. The second section handles the reference image. The processing is quite simple. First, resize the image so that its longest side is 512 pixels. After that, the image is encoded. Just like LTX 2.3, this is a two-stage sampling workflow. The first sampling stage generates the base video. The most important node here is called LTX Video in place, which we already used with version 2.3. Notice that this workflow contains two instances of the node. One is used during base video generation, and the other is used during upscaling. The purpose of this node should already be familiar. It injects the reference image and prompt into the sampling process. During the first stage, we generate a base video at a lower resolution. There are also a few differences in the sampling process. The main one is the LTX-V dual CFG guider, which allows us to adjust the audio CFG and video CFG separately. This differs from LTX 2.3. The fourth step is the second stage, which handles upscaling. Here, we upscale the original video in latent space and sample it again. The resulting video then matches the resolution we specified. There are two other workflows, text-to-video and first and last frame video generation. Both can be built very easily from the image-to-video workflow, so let's focus on their differences. Text-to-video is the simplest. Bypass the LTX Video in place node we just discussed, and the workflow becomes text-to-video. Everything else can remain unchanged. For first and last frame generation, we add two images and use a different node to inject the conditions. Here, we use two LTX VadGuide nodes connected in sequence. Why use this node? Because it allows us to set the position and strength of each reference frame. Since we're providing a first frame and a last frame, their positions are set to 0 and -1, 0 represents the first frame, while -1 represents the final frame. Also note that the official first and last frame workflow doesn't use two-stage sampling. It only has one sampling stage. The next two examples show how to choose and use your first and last frames. In the first example, the story takes place in a hotel lobby. The first and last frames are extremely similar. The character, clothing, environment, and composition are all very close. In the prompt, we simply ask the model to generate a video of the woman closing her umbrella. Let's look at the result. The model successfully generates a single continuous shot, but pay attention when the umbrella closes. The umbrella suddenly becomes soft and flexible, making the result look strange and physically incorrect. Now let's examine the second example. In the first frame, the character is sitting inside a car. By the final frame, she's standing behind the vehicle. The character's position, camera position, and composition all change at the same time. Of course, the prompt also contains a detailed description of the required actions. At first glance, the generated result looks pretty good. But if you watch closely, you'll notice a camera transition in the middle. It isn't actually a single continuous shot. These two examples reveal an important rule. If you want to create a continuous one-shot video, choose first and last frames that are as consistent as possible. If the two frames differ too much, the model may introduce a transition. Next, let's look at text-to-video. In our first test, we ask a travel vlogger to appear successively at the Great Wall, Shibuya in Tokyo, and the Eiffel Tower in Paris. The generated result contains 3 clear scene changes, while the character's outfit, hairstyle, and overall appearance remain basically consistent. This result shows that LTX 2.5 can natively understand multi-shot prompts. But here's another video. Its prompt is also written as a multi-shot prompt, except that all 3 shots remain inside the same old house. Only the shot size and camera direction change. Even though we explicitly wrote 3 shots, the final result is still one continuous take. So multi-shot labels alone don't guarantee visible cuts. When the location remains unchanged and only the framing or camera direction changes, LTX2, the 5th of May, interpret those instructions as one continuous camera move. Now let's test image to video and facial detail. The reference image shows a woman holding a card. In the prompt, we ask her to read the card, look out the window, and finally turn back toward the camera with a very restrained smile. In the result, we can see her gaze shift, her eyes blink. The corners of her mouth change, and the camera move closer. More importantly, even after the camera pushes in, her skin, eyes, and hair don't undergo any major changes. Next, let's use image to video to create a complex action sequence. Our test scene involves repairing a bicycle. The prompt divides the task into several steps. Inspect the chain, rotate the pedals, check the wheel, and finally raise a wrench. That's a fairly complex chain of actions. In the resulting video, most of those actions are successfully performed. The chain, pedals, and wheel also move continuously. This further demonstrates that the new text encoder can understand more complicated action sequences. However, we still encounter the issue I emphasized earlier. When the camera turns toward the bicycle, the character's face temporarily leaves the frame. When her face reappears, her identity looks slightly different. Now let's test a more complex scene involving a mirror reflection inside a dressing room. The character first adjusts her earring while looking into the mirror, then turns away from the vanity and walks through the backstage area toward the stage entrance. In the final result, the movements of the real character and her reflection are basically synchronized. LTX 2.5 handles this type of reflective scene surprisingly well, and the result is very stable. When introducing this model, I also mentioned that it doesn't always follow physical laws particularly well. Let's add another test to see whether that problem really exists. We'll once again use an image of a woman driving, but this time we only provide the first frame. The prompt contains a very complex action sequence. She needs to get out of the car, close the door, get back into the car, and then start the vehicle. The prompt includes both action requirements and camera animation instructions, making this a relatively difficult test. As you can see, the overall story sequence is basically correct. However, the character clips through the area around the car door. This example shows that the model's adherence to physical constraints still needs improvement. The sixth test is simpler. It's another image to video test, but this time the scene contains two people. In the result, both characters hold the picture frame from opposite sides, adjust its position, and finally stabilize it. This example shows that LTX 2.5 has also made clear progress in handling coordinated actions between multiple characters. There's one more issue we can't ignore. In our text-to-video prompt, we explicitly describe the character as a 25-year-old East Asian woman. However, the generated character still looks noticeably older. This problem already existed in LTX 2.3. So when you want to generate a beautiful young female character, I recommend using the word girl instead of woman. After this comprehensive round of testing, it's clear that LTX 2.5 delivers a noticeable improvement. Of course, it still has various limitations, and we've pointed those out as well. When using the model, try to take advantage of its strengths while avoiding the situations where it remains unreliable. That's all for today. Follow me and become someone who truly understands AI.